In this video, we're going to be talking about problem solving in quadratic functions, and in particular, projectile motion problems. So this first example on the left says a ball is thrown straight up from an initial height of 20 feet with an initial velocity of 44 feet per second. The situation is modeled by the equation h of t equals negative 16t squared plus 44t plus 20. How long will it take the ball to hit the ground? Now, it's true that we have done problems like this before, but this is going to be different in the sense that it's not going to be factorable. So we're going to have to use other techniques to solve this. So first of all, how long will it take the ball to hit the ground? Well, when the ball is on the ground, the height is 0. So we're going to replace h of t with 0. And then we're going to solve for how long, for time. Now, whenever we see a quadratic equation, so I know it's quadratic because there's a t squared, and it's in the standard form here of ax squared plus bx plus c. In this case, we're using t instead of x. There's a quadratic formula, or a quadratic function. So, to solve this, we need to get everything on one side and set it equal to 0. Try to factor first. So we don't know if it's factorable or not until we try. So looking at this equation, we always start with our GCF. So negative 16, 44, and 20 all have a 4 in common. And because our leading term is negative, we're going to take out a negative 4. And that's going to leave us with 4t squared plus 11t minus 5. Oh, sorry, not plus, minus 11. Because we took out that negative. So all the signs changed, right? So it was a negative 16, now it's positive 4. Positive 44, now it's a negative 11. And a positive 20 is now negative 5, because we took out negative 4. Then we try to factor. So you don't know it's factorable until you try. And so we want something that's going to multiply to negative 20, right? Because our leading term was 4. So 4 times negative 5 is negative 20. And we want it to add to negative 11. Well, the only factors are 20. So there's 1 and 20, 2 and 10, 4 and 5. None of these, no matter where I put a negative, are going to add up to 11. So it's not factorable. Again, you don't know until you try to factor it. So if it's not factorable, then we can use the quadratic formula. And we still can pull out this GCF, and that's not, we're going to now use these terms for our A, B, and C. The smaller the numbers, the easier it is to deal with. So A is 4, B is negative 11, and C is negative 5. Plugging into our quadratic formula, t will equal negative b, in this case positive 11, right? Because it was negative 11, so negative negative makes it positive, plus or minus the square root of negative 11 squared minus 4 times a times c, all over 2 times a. So again, I'm using these in here. I don't need that GCF to plug in for A, B, and C. Simplify what's under that radical. So 11 times 11 is 121. And negative 4 times negative 5 is going to be positive 80. So 121 plus 80 is going to be 201 under the radical. And then 2 times 4 is 8 in the denominator. Now from there, it says to round to the nearest tenth. So I'm going to go ahead and get out my calculator. I'm going to do 201, take the square root of that. I'm going to take the positive square root first, and then add 11, and then divide by 8. So approximately 3.1 when we round to the tenths. and I need to do the negative radical. So 201, and I want the negative of that. I'm going to add 11 and divide by 8. I get negative 0.4. Now, since this is time, and time was in seconds, can we have a negative time? No, we're not time travelers. There's no negative time here. So at 3.1 seconds, the ball should be on the ground. Alright, go ahead and do the one on the right. It's just instead of being on the ground, now you're going to do it at a specific height. So instead of plugging in 0 for h, you're going to plug in whatever height you're trying to find. Alright, on the right hand side, an object is thrown upward from the top of a 200-foot cliff with a velocity of 12 feet per second. The height h in feet of the object after t seconds is h equals negative 16 t squared plus 12t plus 200. How long after the object is thrown will it be 100 feet from the ground? So in this case, the height is 100. So it's 100 feet from the ground. And we're going to replace h with 100 and solve. So 100 equals negative 16t squared plus 12t plus 200. It's a quadratic, right? We have a t squared here. So we get everything on one side and try to factor. So 0 equals negative 16t squared plus 12t plus 100. 200 minus 100 is 100. I'm going to pull out the GCF first. So I notice they all have a 4 in common. Our leading term was negative, so I'm going to take out a negative as well. It's going to leave us with 4t minus 3t minus 25. So if I'm going to try to factor, I need something that's going to multiply to negative 4 times negative 25 is negative 100, right? Our leading term was 4 here. So negative 100 and add to negative 3. Well, the only factors of 100 are 1 times 100, 2 times 50, 4 times 25, 5 times 20, let's see, not 6, 7, 8, 9, 10 times 10. If I'm looking at all these factors, no matter where I put a negative, I'm not going to get it to add up to negative 3. So again, this is not factorable. So we're going to go to the quadratic formula. And a is going to be 4. So we're going to leave it in this kind of the GCF factored out, so we have smaller numbers. So a is 4, b is negative 3, and c is negative 25. So t will equal negative b, so negative 3 is positive 3, plus or minus the square root of negative 3 squared minus 4 times a times c, all over 2 times a. I'm going to simplify what's under the radical. So negative 3 makes positive 9. And then 4 times 25 is 400. So 16 times 25 is 400. And the two negatives will make it positive. So 9 plus 400 would be 409 underneath the radical. Just multiplying and adding there. And then 2 times 4 is 8. So again, it says round to the nearest tenth. So I can just plug this in the calculator from there. I do 409, take the square root of that, and do the positive square root first, and then plus 3, divide it by 8, and we get 2.9. So t is approximately 2.9 for one solution. The other, same thing, we take 409 square root. Now I want the negative square root, and then I'm going to add 3 and divide by 8, and we get negative 2. We're going to round up to 2. So negative 2.2. Again, this is time, so this problem is about time. I'm not going to have a negative time, so approximately 2.9 seconds. That object should be 100 feet from the ground. And there you have it. So another thing to think about is there could be one, so both of these problems had one time, but it is possible to have 2 times. So if I was throwing something or shooting a rocket, it's going to go up and come back down. So if I wanted this height, it would reach that height at 2 times, versus maybe this height, it's only going to reach it once. Or if I'm throwing something off a cliff, it's going to reach these heights down here only once, right? So you could have 2 answers or just one answer for these types of problems.